So we're starting chapter 17, which is all about radicals, and this section is 3 sections in one. It's 17.1, 17.3, and 17.7. The reason why I teach it as 3 sections in one is because I don't feel like it needs to be 3 sections, kind of like the AC method. The AC method was supposed to be 3 sections. It's supposed to be a trial and error section if your A is 1, and then if your A is anything other than 1. And I'm like, just teach them all the same. And that's kind of the same with this section, okay? So radicals are roots, so like square roots, cube roots, fourth roots. So 17.1 is when they're all perfect roots, so perfect square roots, perfect cube roots. 17.3 is if they're not perfect squares, how do you break them down? Well, to me, I break them down the same. And then 17.7 is a little baby section about how you can't have a negative under an even root. And so we'll talk about all of those, okay? So the principle is always your positive. So that's always your positive, your main root. And then the negative square root, obviously, is your negative square root. It just says if A is a non-negative number, so basically if this is a positive number in here, then the square root of A is the principal of the square root, but then if you have a negative in front, it's just the negative, all right? And that's all it's saying. We're going to talk about perfect squares. We'll talk about non-perfect squares and what to do with it. This guy's a 17.7 right here, this middle paragraph. This is where you're kind of like feel like you've been lied to your whole life. There is a whole nother number system called the complex number system. Did anybody get into the complex number system in college algebra? If you go into college algebra, you'll talk about it. The imaginary unit written I. So I is actually a number, believe it or not. It's the number whose square is -1. You're like, what? There's a number out there when you square it, you get a negative? Yes, that's a whole different number system. But what we care about is anytime you have a negative under a square root, he pops out as I, okay? It says, no, I is only used for square roots. All other even roots are just called not a real number. Again, when we get into them, I'll kind of talk about all of that. Last but not least, guys, before we move on, the nth root of a number is written like this. This is called the index, okay? That little n is the index. They say it right here. It's just basically, is it a square, is it a cube, is it 100th power? That's how many things you're looking for. If it's a square root, it's your default, so they don't ever really write a 2 there. Okay, so if you don't have a number up there, it's just your square root. All right, here are some rules that we have to remember. This chart is on here, but it will also be on 17.2. Remember when you multiply, oops, I can't follow my finger. When you multiply 2 bases, you just add an exponent. When you raise a power to a power, you multiply the exponents. When you have a product raised to power, you can kind of distribute that power to both parts. And same with division, you can kind of distribute to both parts. If you have the same base, you just subtract exponents. We've been doing that. Anything to the 0 power is 1. And then I want to kind of add on here, I feel like I need to add this. This is also true for 1 over a to the negative n is same thing as n. So add that on there. Basically, if you have a negative power, guys, it just means he's in the wrong spot. So if you look at this one, he has a negative power, so he needs a bump to the bottom. But here, if he has a negative power, that means he needs to bump to the top. Okay? A negative power just means he's in the wrong spot. We're not going to do a whole lot with these. We'll do a little bit on the back, but you'll do more in 17.2. All right, we're going to fly through this front page. Why? Because all of these are from 17.1, where they're perfect squares or perfect cubes. All right, so if you have your calculator, feel free to just throw these into your calculator. So what's the square root of 36? 6, right? A square root means what times itself gets you to that number. So how can we do that on our calculator? That's really dark. Your square is the most common one. I'm going to try to do it so where you can see it. He is in the blue, so I'm going to hit second x squared, and you just type 36 in there, and you get 6, all right? Why does that work the old school method, like say you didn't have your calculator? When it's a square root, you're looking for a pair, and what do I have a pair of? 6's. So 6 is your answer there. What's the square root of 0? 0. Yay, not a trick question. You get to 3 and you're like, Molly, I hate fractions. But guess what? Both 4 and 49 are perfect squares. So what's the square root of 4? 2. What's the square root of 49? 7. So guess what the square root of this is? 2/7, all right? 0.25, you kind of have a little bit of an idea, like what's the square root of 25? 5. It's just we don't feel the most comfortable with decimals, like where's the decimal? So I would probably just do that in my calculator. The square root of 0.25, and you get 0.5. Is that okay? Are there any questions with 1 through 4? They're all perfect squares. What times itself gets you to that number? Now, how do we deal with variables? I'll show you the long way once, but then I'll tell you the shortcut. So x to the 6 means what? You got 6 of those little x's, right? You guys agree that x to the 6 is x times itself 6 times? So, how can I split that into 2 even groups? They would have how much in each group? 3. Remember, the square root is what times itself gets you to that? So what's the square root of x to the 6? X to the 3rd. So even though square roots are not division, they're kind of division when they come to powers. So if it's a square root, which is 2, how many times does 2 go into 6? 3 times. So that's why x to the 3rd comes out. Now let's look at this one. It's the same idea. What's the square root of 9? 3. And then what's going to be the square root of x to the 12th? X to the 6, right? If you had 12 x's, how do you put them into 2 equals groups? You'd have 6. Is that okay? Does everybody see where each part comes from? All right. This is where we kind of want to draw the line. If a negative is on the outside, that's fine. That's just called the negative square root. So the negative just kind of hangs out, right, as you take the square root of 81. Well, what's the square root of 81? 9. So this is just negative 9. And that's one where, like, maybe you type negative in your MyMathLab and then break the square root down. This, however, what times itself will give you a negative 81? It doesn't exist. That's kind of why it's called that number I. 9 times 9 gives you a positive 81. Negative 9 times negative 9 gives you a positive 81. There's no number times itself that gives you a negative. So this can't not exist. So that's why they call it 9i. Whenever you have a negative under a square root, and only a square root, it's called 9i. Or just an I, sorry. The I pops out. Or you might have seen something like this, no real number. Because into normal math land, 9i is not a normal number, right? So that's why it's called no real number. In the real number system, this doesn't exist. Now, if we go into the complex land in 17.7, that will exist. Guys, we're only really going to talk about I in this section, okay? Otherwise, we're not going to worry about it. All right, can a negative happen under a cube root? It can. Because what do we know when you multiply an odd amount of negatives? It's negative, all right? So how do you do cube roots in your calculator? What you do is you hit the math button. So the math button's right here. And on number 4, do you see that little cube root right there? You hit 4, and then you type negative 64. So we did this before, I think, when we did the difference of cubes. Do you guys get negative 4 there? Is that all right? So negative can exist under odd indexes. That's an odd index. So it's okay, because a negative times a negative will give you a positive, but then another negative will go back to that negative. So knowing that, guys, what's number 10? What's the cube root of 27? 3. So what's the cube root of negative 27? Negative 3. And then the same rule is going to apply. Up here we had a square root. How can you take 6 things and break it to 2 even groups? You have 3 things. Well, how can we take 9 things and break them into 3 even groups? It's going to be x to the 3rd. The rule is just divide your power by your index, okay? So if we had 9 things, we'd have 3 groups of 3 there. Is that okay? 11 looks scary, but it really isn't because they're both perfect cubes. What's the cube root of 8? 4. Not 4. What times itself 3 times gets you to 8? 2, right? So our numerator will be 2. And then what times itself gets you to 125? What's the cube root of 125? say you're like, I'm not that good with numbers, I can't just do that in my head. Well, you could do them individually or in your calculator. We could do the math button again and scroll down to 4, and you can type 8 divided by 125 and hit enter, and it'll give you decimal. But if you hit math fraction, oh, my battery just died. Oh no. It will give you the 2/5. 0.4 is 2/5. All right, 12's not any harder than the ones we've been doing. How do you take 12 things and split them into 3 even groups? You'll have x to the, not 6, because it's the cube root. 3 goes into 12 4 times. If it was a square root, Sadie, x to the 6, because you split them up equally into 2 groups. So that little index tells you how many groups you have to have. All right, we're rolling. 4th power, how do you do that? Can you steal your calculator since mine died? Okay. 4th power, how do you do that? Well, if it's any power higher than 3, you actually have to type the index first. So type 4 first, because we want to do the 4th power. Then you go to math and you go down to number 5 where it has that random x index. So right there, that's the 4th power of 81. Oopsie, what did I do? Oh, I don't need to close off the parentheses. You get 3. How do I do it? You're like, Molly, I don't have a graphing calculator, or I want to actually know how to do it by hand. This is going to come in handy when we get to the back. We're just going to do factor trees, and this is how many friends we have to find. So what is 81 times 81? What's 81 times 81? Or not 81. What 2 things? What 2 numbers multiplied by 81? No one's going to want to answer that question. And I'm like, I don't know what 81 is. What times itself gets you to 81? 9. Thank you. You can answer that question. And then what does the 9 split up as? 3s. So this is why these indexes work. When you split a number up and you find as many that you need, they get like join elbows and come out as 1, right? What times itself 4 times gets you to 81? 3. So if you see the correct number of things, so this tells you how many things you need, that's the answer there. Okay? The 5th power is pretty high, but guess what? Again, we can type that in our calculator. We can type 5, scroll down to that number 5 in your math, and you do that. What's our sign going to be? An odd with a negative is a negative. Did anybody put that in their calculator already? It is -3, right? But you could break it down. 243 divided by 3 is, forget. I knew that at one point. 81, and then 81 would break down to 4 more 3s. So you'd have 5 3s total. I don't know why this is here, because this is really easy. The negative on the outside is fine. What's the square root of 25? 5. And then here, this is a 4th power, so I does not exist. It only works for square roots, but you can't have a negative, so this is an even power. So this is just no real number. Are there any questions on the front? Is that pretty? Did you guys fly through that pretty quickly?
Can you redo 14 again?
Yeah, 14. In your calculator, type 5. Can you see that? Type 5, and then hit math, and then go down to number 5, and type -243, enter, and you'll get -3 pop out, okay? Or if you needed to do it by hand, you could do 243 divided by 3, you get 81, and 81, so you could just do the factor tree, and you would get 5 3s there. Guys, the front page is 17.1, okay? That's 17.1. So how does that change on the back? Well, on the back, they have us doing a little bit of math. Is that okay if I flip it over? On the back, they have us doing a little bit of math and then breaking it down if we can. So on the back, this is 17.3 technically. So anytime you have the same root, you can just do the multiplication on the inside. So what's 3 times 5? So this is just equivalent to the square root of 15. And then if you could, you would break it down. But does square root of 15 break down? No, it's 3 and 5. There's no pair of anything. So you would be done at that point. On 18, do you guys see that they both have cube roots? So we can do the math. What's 4 times 2? 8. And then you put this in your My Math Lab and you'll get a red X and say, although your answer is correct, it's not completely simplified, because the cube root of 8, we can break it down. What are any two numbers that multiply to be 8? 2 and 4, but what's 4 split up in? Guys, how many things do we need? We need a 3 of one thing, and what do we have? 3 2s, okay? Are you guys too young for a barrel of monkeys? Do you remember that game at all? You're too young, aren't you?
Yeah, I remember it.
Okay, so it's like a plastic barrel and it had a bunch of plastic monkeys and you try to like scoop them all up by hooking their arms. That's kind of what I use for this. In order to come out, this is how many things you need, but they're going to hook arms and just come out as 1 2, okay? They're going to hook arms and come out as 1 2 there. We have enough friends to come out and play. 19, we're going to do the same exact idea. We're just going to multiply straight across the top, straight across the bottom. So this is the square root of 2 times b, or 2b, and z times 3, or 3z. At that point, ask yourself, does either one break down? Nope, 2 is not a perfect cube, or square, b is not a perfect square, 3 is not a perfect square, and z is not a perfect square. So you're done. That's your answer, okay? On 20, we're going to try to break them down. Does 3 break down any? No. So he's going to hang out under the cube root. He doesn't have, or fourth root, excuse me. He's going to hang out under the fourth root. He does not have any friends, okay? But how can you split 16 up? What's any two numbers that multiply to be 16? 4 and 4. But what are both of our 4 split up as? 2 and 2. So remember, this is the number of friends we need in order to come out and play. How many friends do we need? 4. Guess what we have? 4 2s. And then what about the Y? Does he have enough friends to come out and play? Yeah. So how does this answer work? It looks kind of weird, but think about levels of a house. The 3 is on the upstairs, so he's going to stay on the upstairs. So he's still the 4th root of 3. He couldn't come out at all, okay? But in the bottom, they have a walkout basement. They're coming out to play here, all right? Who can come out? The 2. And then how many Y's are going to come out?
Y to the third? 1.
Just 1, right? So think about y to the 4th, what it is. It's 4 y's. So remember, whenever you have that many friends, you hook arms and come out as 1. Or the divisibility rule, right? How many times does 4 go into 4? 1 time. Look how weird that answer is, but you guys did it, okay?
So that would, all of that would be over 2y?
Yes, okay? So like I said, kind of think of levels of the house. If you can break down the top, awesome. If you can break down the bottom, awesome. But if you only can do one or the other, leave them where they are, right? So 3 had no friends. He had to stay inside the house. So he's still under the 4th root. But 16 had enough 2's to come out and play, and Y had enough 2's to come out and play. All right, let's look at 50. What are any two numbers that multiply to be 50? 10 and 5. And then how does 10 split up? 5 and 2, right? Think the multiplication, right? So do you have a pair? Yeah. Why did I just want a pair? Because this is a square root, right? You can put a 2 there if you want. So guess who can come out and play? The 5. Who has to stay inside the house? The 2. Isn't that crazy, guys? So what we're doing is we're basically simplifying radicals. So you know how like 8 over 10 is not reduced? That reduces to 4/5. This is the same idea. Square root of 50 is not completely reduced. 5 root 2. And if you put it in your calculator, they are the same answer. So if you put the square root of 50 in your calculator, you get this crazy number, right? It's not a perfect square. But if you do 5 root 2, you get that exact same number. They're equivalent, they're just in simplified form, all right? And you'll learn a little bit further on why it's easier to deal with this, okay? And that we'll learn in 17.2. It's easier when they're simplified because we can do math a little bit easier. All right, let's look at 54. What are any two numbers that multiply to be 54? It's even, so what number goes into it for sure? 2. And that's what I do. If it's an even number that I'm not very familiar with, do it divided by 2. What's 54 divided by 2? 27. So we have 2 and 27. But why does that help us? Well, 27 can break up. What does 27 break up as? What are any two numbers that multiply to be 27?
3 and 9.
3 and 9. And then how does 9 split up? 3 and 3. So you look at this, and we're just going to look at 54 first, and then we'll worry about the x and the y, okay? Whenever it comes to who can come out and play, this is the mean guy that gets to choose. And he says you have to have 3 friends in order to come out and play. So who can come out and play?
3.
The 3. Let's stop there for now, though, because we got to go to the x's and see if any x's can come out and play with the 3, and we'll see if any y's can come out and play. All right? So we'll write the 3. He's going to come out and play. We can't forget about that 2. He has to stay inside, but we'll worry about him in a second. How many x's can come out and play?
2, 3.
Well, it's a cube root, right? So since we have 6 there, she's thinking square root, right? 3. But since we have 6 and we have to have 3 come out at once, how many are going to come out? 2. It's just that divisibility rule. What's 6 divided by 2, or 3? 2. Now, we haven't seen this yet with the y. Do you guys agree that 3 goes into 8? But not perfectly. So that means some of them can come out, but some of them are going to stay in, okay? So how many times does 3 go into 8?
2.
2 times. So guess how many get to come out? 2. But what would be our remainder?
1.
Not 1, but 2, right? Do you guys agree that, like, if we did long division, do you guys remember doing long division? It's awful. So what we do is long division, basically, right? How many times does 3 go into 8? Twice, and that gets us to 6, and then this is your remainder. Do you remember doing that? That's how we're going to do with our variables. This is how many get to come out to play. This is how many have to stay inside, okay? So let's go back and look at our number. The 3 could come out. Here he is. All x's could come out, and then 2 of the y's could come out. But who remains in our cube root house? The 2 and 2 y's. Look how ugly that is. Does everybody see where everything came from? So cube root means you need 3 friends. So the 54 split up into 2 and 27, but the 27 gave us 3 3s. So there was our 3 friends, so the 3 could come out and play. The 2 didn't have any friends, so he had to stay inside. Then 3 went into 6 perfectly, so that's why all the x's come out, x squared. And then 3 went to y not perfectly. It went in there twice, so that's why squareds come out, but it left 2, and so that's why 2 are left inside. You feel bad for them. They need some friends. 5 root 2 is our answer. Okay, look how horrible this is. All right, so what we're going to do here with this division problem is kind of similar to what we did up here. When they have the same root, you can do the math. So on 17, 18, and 19, they all had the same root, so we could do the multiplication. That's what I'm going to do on number 23. Notice they're both cube roots, so I'm going to make it one giant root. So the 7 hangs out, and this is going to be the cube root of 48x to the 4th, y to the 8th, all over 6y squared. So I'm just writing it as one cube root because 6 goes into 48, which will give me a normal number. Y squared goes into y to the 8th. So I'm able to kind of get rid of my fraction when I do it this way, okay? So the 7 will hang out as we approach the root. All right, so let the 7 hang out, and we're going to write the cube root. And we can write a small cube root now because everything goes in evenly. What is 48 divided by 6? 8. Did we touch the x's? No, there's no x's down here, so we still have x to the 4th. And then this was a property that we learned, in 112. But remember when you divide bases, what do you do with the exponents? You actually subtract. Is that okay? So what is y to the 8th over y to the 2nd? That ends up being what? Y to what power? The 6th. When I teach 112, I just say it like it's like a boxing match, right? These 2 y's take out 2 of his y's, but then 6 remain. At this point, guys, we've made it look like number 22, okay? The 7 will hang out, and as things come out of our root house, they'll multiply by that 7, okay? So let the 7 hang out, and we're going to go ahead and approach the cube root of 8, x to the 4th, y to the 6th. How does 8 split up? 2 and 4. But how does 4 split up?
2 and 2.
Some of you guys might get familiar, and you know the cube root of 8 is 2, and that's fine. Like, you might get familiar with it. So we have a 7 out here. He's hanging out, but then who else can come out and play with him? The 2. The 2's from the 8, absolutely, okay? And again, they're going to be multiplied. They just multiply, okay? All right, 3 goes into 4 not evenly, but it does go in once. So how many x's can come out? 1, but then there's going to be a 1 remainder. What? 1 remains. All right, what about the 3 into the 6? 2, and perfectly, right? So who's the only guy left in our cube root house? That 1x. Poor little guy, okay? So the 8 was a perfect cube. It broke down to 3 2, so he came out to multiply by that 7. 3 goes into 4 one time, so 1x came out with a remainder of 1, so that's why he's under there. And then 3 goes into 6 twice, so that's how why 2 gets come out. At the very end, guys, what my math lab's going to want you to do is the actual multiplication. What's 7 times 2? 14, okay? So the final answer is 14x y squared times the cube root of x. Look how ugly that is. Gosh. But believe it or not, making it look like that is going to make it easier for math down the road. And I know you don't believe me yet, but it does, okay? So remember, whenever 7's out here on the outside, he's just being multiplied by whatever comes out. All right, let's do that with this 24. It's the same exact idea. That 2 is going to hang out as we take a giant 4th root of 32a to the 8th, b to the 6th, all over a to the negative 1, b to the 2nd. Okay? So that 2 is going to hang out as we do the math under the 4th root first. And then, after we do the math under the 4th root, he can come out and play. Alright? So the 2 will hang out. Let's write it as one single 4th root. Notice we had no numbers on here, so 32 is going to stay 32. And then, guys, this is something different. This is not just 1, because if it was just 1, that would be a to the 7th. But since it's negative 1, when he bumps up, he actually adds. Or what happens when you subtract a negative? You add, okay? So instead of knocking out one of the a's, he joins the a's. So now we're a to the 9th, okay? And then how many b's are we going to have? 4 of them. Is that all right, guys? Because we had 6 up here and 2 down here. These 2 knocked out 2 of theirs. At that point, we've reduced it to like number 22 again. Let 2 hang out as we break down 32. Some of you guys might know the 4th root of 32, but he's not perfect. So let's go ahead and break them down. What are any 2 numbers that multiply to be 32? 8 times 4, perfect. And then we know 8 breaks down as 2 and 4. And that 4 breaks down to 2 2s. Oh my gosh, he has lots of 2s in him. Go back up to the 4, and we have 2 2s. So 32, guys, is actually 2 to the 5th. There's 5 2s there. But we don't care about all 5. How many do we care about according to this mean guy? Just 4 of them, okay? So we have 4 of them. But I'm going to put a little asterisk by him so we don't forget he's left inside. He's so small, it's easy to forget that he's there, okay? So we had 8 times 4, but the 8 split up to 2 and 4, or 2 times 2. So 8 itself gave us 3 2s, and the 4 gave us 2 more, but we only care about 4 of them, all right? So this 2 is already out there. He's already out there waiting, and he's going to come join them. Another 2. They're going to hook arms like a barrel of monkeys and come out. Let's focus on our variables now. Let's not forget that little 2's on the inside, but let's focus on our variables. How many times does 4 go into 9? 2 times. So a to the 2nd is going to come out, but do you guys agree that there's a remainder of 1? 1 remains. And then how many times does 4 go into 4? just once, right? If it was 2, you're so used to square roots that you want to do square roots, but 4 goes into 4 once, so 1b will come out. So what does that mean? It means all these 2's came out except for this 2, so we still have under the 4th root a 2, and then all the a's came out, 4 went into 9 2 times with a remainder of 1, so 1a remains. So our final answer, guys, is 2 times 2 out in front, which is 4, a squared b times the 4th root of 2a. Oh my goodness. I know my analogies are stupid, but think of it that way. This is like the mean guy that says that's how many friends you need, and you only can play with friends that look like you. This is all kinds of wrong, right? And then when you come out, you just multiply right in a row. All right? This is the hardest stuff right there. 22, 23, 24 is the hardest stuff. This is 17.3. All right? The second part of 17.3 says, well, where in real life do you actually see radicals? Well, if you're going on to college algebra, you're actually going to start graphing them, okay? So notice we have function notation. This is called f of x, and they use the square root of x minus 4. This is called g of x, and it's the cube root of x plus 2. Function notation, f of x and g of x, are just a fancy way of saying y, okay? F, G, H of x, cat of x, I don't care, okay? It just means, here's my function, and whatever's in the parentheses, that's my x, shove it in, okay? So if like we wanted to graph this, the ordered pair would be, this is our x value, right? So we're going to find out what f of 8 is. Since it's f, I need to pick the f function, which says take your x value, which in this case is 8, minus 4, and then find the square root. Order of operations, roots are like a grouping method, so it's kind of like parentheses, so you have to do what's under your root first, okay? So f of 8 is just the square root of 4, but what's the square root of 4? 2. So on my math lab, I believe they just want you to put 2, but something I want to point out to you guys is that you just found an ordered pair. Like if we were going to graph this function, what did we plug in for our x value? 8. What came out for our y value? 2. So if we were to graph this, 8, 2 would be on our graph. Just so you kind of try to connect the dots for you, okay? F of 6 is the same thing. Since it's the f function, we're going to use this function over here, which is the square root of x, which is 6 minus 4. You put that in, and you just get the square root of 2, and they want you to leave it like that, okay? So that's our final answer, the square root of 2, but again, an ordered pair would be 6 was my x, root 2 came out as my y. On 27 and 28, we're doing the exact same thing, but it's with the g, okay? So since it's with g, we're going to use the second function, the cube root one, okay? So g of negative 1 says take your g function, which is the cube root, of your x, negative 1 plus 2. So notice I just plugged in my x value of negative 1 in there. What is negative 1 plus 2? 1. But what's the cube root of 1? Just 1, okay? 1 can be any root. The cube root of 1 is 1. The 100th root of 1 is 1. So 1 is going to be your final answer. But again, if you were to graph this function, the ordered pair would be negative 1, 1. All right, last one. We have another g. So I'm going to grab that function again, g of 1. And we have the cube root of x plus 2, or 1 plus 2. But 1 plus 2 is just 3. 3 is the only guy in there, so he doesn't break down any, so he's your final answer, the cube root of 3. And again, if we were to graph this, on the graph it would be 1 cube root of 3. So they're just making sure like you can evaluate, but when do you have to evaluate is a lot of times when you're going to graph this. This, guys, is actually the opposite of a parabola. So you know how a parabola looks like an arch up and down? He's actually sideways. So he's a parabola on the side. And this cubic function, if you go on to graph it, he actually looks like a snake. So he like slithers kind of, and that's how you'd graph it. All right, the last one, I believe you guys have seen the distance formula before. So I always write D equals. Anytime you have to find the distance between 2 points, it's actually derived from the Pythagorean theorem. The, you know, one leg squared plus the other leg squared equals your hypotenuse squared. Well, the hypotenuse squared is your distance, okay? So down here they gave you 2 points. So if you wanted to graph 2, -5 and 1, -4 in your xy plane, if you wanted to connect them the way the crow flies, how far is that distance, okay? So this is just x1, y1, x2, y2. Honestly, it doesn't matter which one you put first because you end up squaring it in the long run. But so we'll have d equals the square root of 1 minus 2, quantity squared, plus -4 minus a -5, the quantity squared. And it gets kind of a little iffy with all those negatives, okay? So x2 minus x1, so 1 minus 2, the quantity squared, plus y2, -4, minus y1, -5, the quantity squared. And again, just kind of work from the inside out. So the square root's the very last thing you're going to do. So we'll do the math inside the parentheses. So 1 minus 2 is a -1. We can't forget to square it at the end. -4 plus 5 is what we have there, because two negatives make a positive. So d equals -1 squared plus +1 squared. Does that look okay? So I let him hang out as I did this math. -4 minus a -5 is really +5. -4 plus 5 is 1. Whether you square a +1 or a -1, they're both 1. So right here, don't try to take the square root of the square. It's not the same when you have a plus or minus there. So you actually have to do the math first. 1 plus 1 is 2. So the distance, guys, is the square root of 2. That is your exact distance. So when they say give it as an exact, you'll write the square root of 2. But if you were going to plot that, you're like, what the heck is the square root of 2? I don't know what the square root of 2 is. Throw the square root of 2 in your calculator to get a decimal answer, okay? So this is the exact. And I'm going to put the squiggly equal sign, which means approximately. What's the square root of 2 to 3 decimals? Because that will be our approximate.
1.414.
Perfect, 1.414. And to me, that makes more sense. If I was going to graph it, I know it's a little, almost like 1.5, right? But square root of 2, I'm like, I don't know what square root of 2 is. So the difference between these 2 points are a little bit more than 1 unit away.